Sarah and Eva were swimming. Use the ratio tables below to determine who the faster swimmer is. So we talk about how fast something is in distance per time, like miles per hour, meters per second, and in this case, we're going to use meters per minute. So we are going to set our ratio up that way. The meters, we have 75 meters for 3 minutes for Sarah. And for Eva, we have 52 meters per 2 minutes. 75 divided by 3 is 25. 52 divided by 2 is 26. So whose speed is faster? If this were in miles per hour, we would want the bigger number to be the one that is faster. So this is meters per minute, which means Eva is faster because 26 is greater than 25. Then in part B it says, explain the method that you use to determine your answer. We found the value of the ratios. Number 2. A 120-pound person would weigh about 20 pounds on the Earth's moon. A 150-pound person would weigh about 28 pounds on Io, which is a moon on Jupiter. Use ratio tables to determine which moon would make a person weigh the most. So we have 120 to 20 for Earth's moon, and for Jupiter's moon we have 150 to 28. 120, we can get rid of the tens or divide a 10 out, and that would be 12 and 2. Then we can divide a 2 out and we'd get 6 to 1 as our ratio. Over here, they're both even, so we can divide a 2 out of it. 28 divided by 2 is 14, and 150 divided by 2 is 75. We could also adjust this one, so 1 times 14 is 14, and 6 times 14 is 84. So that's when the moons are the same amount. But what about when the person is weighing the same amount? Let's try and build our way up. The next one would be twice as much. And then we would add another 120 onto that. And another 20 on the bottom. For this guy, we're going to add 150 each time on the top. And 28 on the bottom. So if a person weighed 600 pounds, on Io, Jupiter's moon, they would weigh 112 pounds, and on our moon, they would weigh 100 pounds. So when it says which moon would make a person weigh more, it would be Io, which is Jupiter's moon.